Okay. How many times have you guys walked past one of these stones without realizing that it represents the way to the future? This stone here is called a pebble. You probably know it. And it represents the inspiration to our 2 years' work. Its name translates into the PEB, and its shapes, most importantly, translates into the prototype that Team 6 today is proud to share with you. Now, if you want to get from a scratchy idea, from a simple sketch on a paper to a real prototype, you need to deal with a lot of topics. So we will be more than happy to fill you in marketing, design, engineering, and manufacturing. And lastly, we'll be more than happy to merge all this together to give an overview of how we made a ready-to-go on the market prototype. So this is a very quick recap of how we split up the roles during these years. And this is a very quick recap of the last year schedule that we had to follow. If you can see, you may notice that the last period was a little bit, let's say, rushy. We're not hiding it, but there's a reason why we did. Unfortunately, it is not possible to do the impossible without rushing. So there's a reason why we did this. We had to rush because we wanted to make the impossible a reality. So what is our starting point? The starting point is basically the feedback that we got last year in Toluca's forum. It was a very positive feedback, especially from an engineering design point of view. So the judges appreciated a lot our work, but we knew that it was not enough. We needed to play tough to get things ready, to get things forward. And as you move forward, more questions may arise, more doubts may arise. More doubts about a lot of topics, a lot of things regarding engineering, regarding marketing, regarding how we can manufacture in the market this prototype, ready to, get it ready to use for the users on the market. And so we started answering to these questions along the year. And what's the final result after 2 years of hard work? Well, it's the 2K18 PEB vehicle, which is here. I'm really proud to fill you in with the most important features of this prototype with the following video, which is trying to show the most important features. Well, I think now it's time to get more into details. I would probably start talking about the marketing. And I'm happy to introduce to you my colleague from Tongji University, Lovecraft. Please welcome him on the stage.
Nice to see you, ladies and gentlemen. This year, our marketing work was divided into 3 parts. Let's go for development of year 1 customer insight first. As you can see in this sheet, it shows us the basic rules of our marketing analysis. Starting from the practical problem, we use statistical skills to identify them, and then we offered statistical and practical solutions. In the end, we made some control plan to gain more feedbacks, also more suggestions. By doing so, we can come out with the final results. Surrounding the voice of customer and the voice of process, we recognize and we realize. This year, we have chosen 5 aspects to optimize our PEB. As you can see, we surveyed about how important they are to our customers, and then we ranked their priorities to determine what to consider firstly in further development. In this year, we made every decision according to this rank. And the emphasis has new content to our concept. Through analyzing the essence of PEB and existing problems of our old concept, we add these 3 keywords into our new concept. They are user-friendliness, mobility, and affordability. Correspondingly, we use the 3 methods to carry investigations on them: giving offline questionnaires, intercept interview, and field research. Starting from affordability, we firstly investigated about what price our customer could accept. As you can see, the target price isn't very high. It's a challenging work. The task for our engineering and manufacturing to control the unit cost became very awkward. Also, we have to give up those functions which are very costly but were demanded by few people. As for user-friendliness, we think the design of PEB need to consider elders' physical condition, so it could be more suitable for them. Also, it needs to be convenient to carry and move with our users. It's easy and safe to drive. That's a basic requirement. So we surveyed about Shanghai elders' physical conditions first. As you can see, many of them suffered from an aged body. Having known their problems, we came up with new proposals for PEB to deal with them. And then we brought some of those proposals into iterative research to confirm the leads of them. The result is shown on the left. Also, you can see different functions faced different levels of demand, but due to limitation of time and cost, we only made a plan to realize those functions which were demanded by at least 30% of people. Moreover, we'd like to design a phone app for our users. Because the data has shown the popularizing rate of smartphone is much more inspiring than last year. Detailed functions about phone app will be introduced in design part. So let's move on. As for mobility, we think the good connection between public transportation will be the basic requirement for PEB because it's a PUMA solution. But it needs to have a more comfortable driving experience for our users and also a better compatibility with the environments in Shanghai. It needs to suit the city and our customers at the same time. So we carried the field research. These 3 places are just for example. We investigated many places like that, where users often go through. We concluded their features, and then we think deeply about what problems our PEB might encounter in this place. And then we offered new solutions to deal with those problems. For example, at the bottom of this sheet, you can see a big size wheel to prevent from the gaps between the subway and the platform. There are many examples like this. By doing so, our user could use our PEB with more pleasure but less concern. So, having known the needs, having offered the proposals, next step was to gain more feedbacks. We need to know customers' attitudes towards our functions. We need to know their suggestions about our further development. And then we could do more adjustments and came up with the final schemes. For example, we offered 2 solutions for smart following. And then we bring it to our customers and ask them, which one do you think is better? And the data will tell us their thoughts. We choose to realize the ultrasonic feedback control because more people think it will be good. The same progress goes for brake proposals. They're handbrake and also foot brakes. Responding to bicycles and motorbikes, which are very popular in Shanghai, we want to know which one our customer prefer. So we also bring them into iterative research, and the data will tell all the truth. Handbrake, yes, then we choose to realize it. In the end, I'd like to introduce our future improvements to you, the cargo proposal. Due to some problems in manufacturing, we didn't bring it into reality this year. But we have offered different proposals, and we have known the choice of our customers. The container in the hubless wheel will be a best one. So after finishing more optimization in the near future, our PEB will embrace a cargo of its own. As you can see, through marketing work, we link our product to our customers. We have made them part of our development team by listening to their guidance, listening to their voice. We have recognized their needs, we have offered solutions, and now it's time for designing and engineering to realize it. Now, let's welcome Sarah for more details.
Hello, ladies and gentlemen. Now, let's talk about the design of the PEB. We started off with the challenges from year 1. Last year, the judges told us that they really liked the simple body language of the PEB and the smart design. So the main focus by realizing the shell was on keeping these characteristics. Due to the realization of the engineering, we had to adapt the shell. You can see the new design on the right-hand side. We still kept it really slim and avoided creating some useless space. So here you can see our beautiful main shell. It's impact resistant and waterproof, and it's divided in 4 main parts, which makes it really easy to assemble them. The same characteristics you can find in the shell design of the footrest and in the handlebar. The footrest shell benefits the user to put his feet on and protects the steering system, which makes the PEB really safe. So the handlebar still kept foldable, but it's improved in ergonomics for the user. So let's talk about the design of the phone app. It is the direct connection between the user and the PEB. The user can choose between 3 main functions. The first one is the basic functions. For example, you can lock your PEB, or the superior functions like navigation, and the user can check the state of the vehicle anytime. So, due to more market research, we invented more design features to improve the user-friendliness of the PEB. So now the user can check the power and speed on the display on the handlebars anytime. And the user can start shopping in the hubless wheel. Furthermore, we invented a really large touchscreen for elder people to have a proper look on it. And the seat is adjustable depending to the height of the user. The supporting wheels enable the user to pull the PB behind you. So now that we heard a lot about the design of the PB, I hand over to Gianluca again to tell you more about the realization of the engineering.
What we have seen so far, I mean, in my opinion, I hope you agree on that, is pretty cool to see. But how do you actually make it? How do you actually get those design features into reality? Well, let's start from the structural frame. Structured frame is probably one of the most important features that needs to handle all the loads, but at the same time, it needs to respect the design. That's one of the key points of today's work that we're going to present, and last year's work. Sometimes design needs to change due to the engineering problems. This is not our case. Engineering just followed the design. I'm sure that this is the first time in PACE history that the engineering is adapting itself to the design and not the opposite. And we're really proud of this because we really wanted to keep the design as it was, as good looking as it was. So, talking about the structural frame, we designed most of the parts. Let's say that a very low percentage of them are commercially available. And this means that we struggled a lot to get all the things done the way they should to fit in the design shell. From a more technical point of view, we have chosen to use aluminum alloys, mainly 7075 and 6082, due to their very high stiffness and their lightweight, because we wanted to keep the weight as low as possible. Moreover, we decided to use as many bolted joints as possible. And the reason why we did this is that we wanted to avoid welded joints as much as possible to make the frame as modular as possible for disassembling, for fixing any damaged part without getting welded joints out and get them welded again. Even because, TIG welding is very expensive, this is another important feature. So we try to keep these components connected without welds as much as possible to keep the cost down. So that's the hubless wheel, and that's most importantly, this is certainly the most important feature in our PB. It doesn't have any central shaft, and that's the key challenge that we had to face. Last year, we suggested this gear-driven system, but we had to change it, especially due to the judges' feedback. So we turned into a pulley-driven system, pulley and belt-driven system, and this has kept costs down, manufacturing costs down. It's much easier to manufacture, and most importantly, it keeps noise and vibrations down. So there's another key component here in the hubless wheel, and that's the clamping system. That's the name that we're giving to the connection part, the connection components between the rotating part, so that's the wheel, and the non-rotating one, so the outer shell. And as you can see in the picture right at the bottom, there are key elements that are trying to keep the friction down. So those needles, those rollers over there, they're trying to keep the friction down whilst rotating. But how does the hubless wheel get moved from the motor, which is in the upper part of the frame? Well, the transmission system that we have designed, as I told you before, is mainly driven by a belt. And as you can see, there are basically three main components. So the motor pulley that is right at the top, and then the driven pulley, which is the one that respects the features of the hubless wheel. We have designed a transmission ratio so as to keep the speed as safe as possible. We had some constraints about speed. and we did design it to keep the performance as high as possible in terms of torque. And there's another feature that I would like to highlight, and that's the belt tensioner. It is not only a mechanical component, but this is another example of how we try to keep the design as fixed as possible, because it allows the belt to run along the track of the shell without going out of it. But this is not the only subassembly that we have designed. So I told you before, we have designed a lot of more subassemblies by ourselves, so they're custom design. And I would like to welcome Lorenzo to talk about the further subassemblies more in details.
Thank you, and good morning, everybody. We now have a focus on some of the most important engineering features that we have developed during this year on our PEB. Let's start from the folding system, which is, of course, one of the most important features of the vehicle. That's why we have to reduce the volume of the vehicle in order to make it carryable as a trolley bag. How we've done this? We used a latch on a slider located near the front suspension to allow rotating movement of the frontal footrest. That allows to reduce the volume, and with a second latch, we can attach the footrest in vertical position. Of course, on just one wheel, it's not possible for the PEB to stand alone. And that's why we added two frontal little wheels that allowed also the PEB to be carried as a trolley bag by the user. Why we designed in this way? We try to make the design of these parts as easy as possible for the user, as simple and fast, to have a simple and fast folding mechanism. Let's now talk about brakes. We have two different kinds of brakes. The first one is the brake that we have during the driving mode, which is a mechanical brake for safety reasons, and also to have the best braking possible. We simply chosen a bike brake to make it simple and safe. There's another brake, which is a regenerative brake that is used during the companion mode. In the companion mode, the motor is able to dissipate the kinetic energy of the vehicle by sending a current to the battery and recharging it. If the battery is fully charged, it's not possible to recharge it more, so we added a chopper to dissipate that current. Let's now have a look to the steering. We had the problem of a moving part on which we had to locate the steering. How we've done it? We took inspiration from the carts for the lower part of the steering, and then we used the cable transmission to send the rotating movement of the handlebar from the handlebar to the wheels. We took inspiration, of course, from bike or motorbikes to make the steering as intuitive as possible. What about the seat? The seat has two important features, I think. The first one is that it's an adjustable seat. That's because we want the PEB to be used by all kinds of users of every height. So we've made it with two gas dampers, which is adjustable in height, and also are useful to dissipate vibrations or bumps. The handle system, as I told before, is similar to one of the bike. It's really simple. It's just an handle that, with a throttle and brake. The important feature on that is not just the two screens that you see before that are useful for navigation or for the user to see velocity and the battery of the vehicle, but also it is also foldable to reduce the height of the prototype. How we've seen all those features in separate slides, but we've followed a full project procedure to make it work all together. We've followed two principles in deciding where to put all those things, all those features, and which dimension they have to have. The first one is the design that we mentioned before, and the second one is the ergonomics, the user, which is at the center of our attention. So we've done an ergonomic analysis with a simulation with software that allowed us to verify the position of the human body on the pad before having it realized in reality. And we have, in this way, been able to decide the position and the dimension of all the components of the vehicle. That's not the only analysis that we've done, because we also run dynamic analysis in order to verify the work of the vehicle and also to develop it. From this analysis that we carry on acceleration, braking, and bump analysis, we took also important information that we used for not just for the design, but also for the second part of analysis, which are the structural analysis. We've done several structural analyses in all the most important part of the chassis of the shell. Here we see an example of an analysis. We have done those analyses not just to verify the strength, the right strength and stiffness of the structure, but also to have important information to further develop the prototype during the engineering design. We see an example of a very critical part on the frontal footrest that we tested not just from a design point of view, but also thinking of manufacturing. You know, those parts are two tubulars connected by a welding, and we had to test it properly to have low tension and to be sure that nothing bad occurs during the use of this critical part. Let's now talk about electronics. The most important thing to say about electronics, in my opinion, is that it has been fully developed by us, and that every line of code that are inside the PEB has been totally written by members of the team. So that's something we are quite proud of. We can split all the electronics components in three categories. The first one is the part that we need for the driving mode. The main brain of the PEB, the electronic part of the PEB, is the STM board that we see in the center of that circle. And that controls all the other components, such as lights, the motor, and the battery, taking signals that come from the user from brakes and throttle. For the companion mode, we still have the STM board as a main brain. There's just a few changes from before. We always have the motor and the battery, but we have an input not from the throttle, but from the ultrasonic sensor, which is a Doppler effect sensor located on the front of the vehicle that allows to recognize the position of the user in order to allow the PEV to follow him. Let's now talk about the infotainment part, which is totally controlled by a different board, a Raspberry board, which connects all those features that are important for the user, for a good use of the vehicle, which is not just driving, but also something more, such as the navigation system, a touch screen, and so on. We see also that we used the Raspberry to control the functionality of the PEB, and to give an example, to turn it on or to shift from the driving mode to the companion mode. That's all for the engineering design, and we will now see how this engineering design has been translated in reality with the study of the manufacturing process. Let me give the word to my colleague. Thank you.
Hello, everyone. I'm Wei Zhang from Tongji University, and I'm here to introduce you the manufacturing part of our PEB. This part involves the business plan, the design for manufacturability, the planned layout, and the manufacturing analysis. According to the feedback from our manufacturer, in mass production, the unit cost of a PEB will be about $845, which includes the standard parts and the manufactured parts. But there are other costs like delivery, sales, wastage, and salary. So at the present, we estimate that a total unit cost will be about $920. If we set the profit ratio at about 14%, the market price of a PEB will be $1,050, which is a bit higher than expected. And despite our hard work, the overpricing will be consequences. But we can lower down the risks. In production, we can lower down the cost by improving techniques, by reducing the wastage, and optimizing the production mode. On the other hand, in marketing, we can promote our customers' expectations. Okay. We calculated the market volume by sample analysis. We have taken the population of Shanghai, the proportion of our customers, the price for PEB, and many other factors into consideration. And the outcome is more than 100 million. When talking about the manufacturability, the first question is why? Why we would do that? The first reason is the cost. As you can see at the very beginning, last year we did a lot of brave and courageous design, and our model was beautiful and simple. But that beauty comes along with a great cost. The second reason is the stability. Last year, we mainly focused on the idea and the function. So the structured design was quite brief, and many of them are weak due to lack of consideration. And the third reason is acceptability. During our first surveys, we found that
the old people tend to accept traditional things. So we think it's better for them if they can ride the PEB like a normal bicycle. So considering the factors above, we made a few adjustments to our model. The details are told in the engineering part, and you can see the changes of our model. In summary, we aim to enhance strength, to reduce cost, to simplify manufacturing, and to promote stability. When designing the processing area, we mainly follow the principle of product specialization and assist with process specialization. The molding and the heat treatment center, the heat treatment workshop locates in the center of the factory, so they can provide molding and heat treatment for other parts. So in this way, we can reduce the cost for transportation and promote the utilization of our equipments. As for the assembly line, we adopted such a layout that has a main line and two lateral lines. In the main line, the components are installed onto the body framework step by step, generally from the inside parts to the outside parts. And the hubless wheel and the pedal are relatively complete and independent, so we designed the lateral lines for both of them. By adopting such a layout, we can keep the various processes in a consistent rhythm. Automatic guided vehicles has been playing an important part in intralogistics ever since the 1980s. And General Motors is one of the leading companies in this field. AGV is a kind of intelligent robot that can automatically run without a man riding it. Remote control will be quite easy if we use AGVs to transport components. And by the way, shipping a cargo is quite a boring job, so we believe it's better to have robots do it, because humans can get tired or bored after working a long time, but robots will never. However, it's not easy to apply AGV into practice. There are several problems, and we have a general idea about it. For navigation, since the AGV is used indoors, we think laser and structured light will be good options because they are accurate and fast. For path decision, we think the particle swarm optimization will be good because for the same reason, it runs fast. However, for general traffic control, we believe genetic algorithm will be better because once the production is stabilized, the situation won't change so fast. So genetic algorithm can search a global optimization. A global optimal solution. Safety is about protection and care. In production of PEB, safety has three aspects. The processing area, the assembly line, and the transportation. To ensure the safety of the workers as well as the devices, we have to set up a perfect protection system, which involves a lot of things. But the most important is a set of safety rules to keep in mind. We care about the protection of the environment, so we did this research about carbon footprint. We mapped the flow of the carbon in order to know how could we reduce the emission of carbon dioxide. The items in the figures are the elements that contribute more than 1% of the entire carbon footprint, and the others are not substantial emissions, and they can be directly ignored. The PEB is designed to use recyclable material everywhere possible. The tires, the plastic, the metal, and the battery are all recyclable. So that is all about the manufacturing part of PEB. Now let's welcome Gianluca to make a conclusion to our presentation.
So a few minutes ago, we started from this stone. We started from this pebble. And we have explained how we have translated this idea, this shape, into something that can be real, something that can be manufactured. Most importantly, something that is ready to go on the market. We have translated all these things from different points of view, so we have dealt with different fields. But now my question is, what is the point of working so hard to keep all these things on a screen? What is the point of getting sleepless nights, as we did, as the whole team did, to get all these things on a software, on a computer, or maybe just on a mock-up, as we did last year in Toluca's forum? What is the point of working hard, of playing tough, without getting to the final point, without getting to the reality of the vehicle? I'll tell you, there is no point. There is no point because the main focus of the team was not getting these things on a screen. The target of the team was getting these things into reality. And I'll tell you what, we did it. We were not expecting to get this good results, but we did it. And we're proud to share this with you because we have get these things done into reality. We're proud to share them with you today, and we're proud to share them with you right now. Ladies and gentlemen, please welcome on the stage our PEB vehicle. And now, let me say that Andrea is ready to light up your future. Thank you.
Thank you very much. Please give them a hand. Nice. Is there a question from the people here? We can take a couple of questions. I know the judges will have a special session tomorrow with them, but if there is any question on the floor, please raise your hand. I cannot see very well, as Jim said in the morning. There's a. All right. Thank you very much, guys. And next team, I believe, is Team 3. I assume they're ready to come on the floor, on the stage. Yes, you are.